When I think about solving proportions, I automatically think about this idea of cross-multiplication, which is a process that everybody seems to love in math, but never knows when to actually use appropriately. So I look at my proportion, which is fraction equals fraction, and I have it right in front of me. And the first thing I need to do is cross-multiply to get rid of the fractions. So I multiply up that way. I have 2 times 4x plus 2. Now I need to show somehow that the 2 is being multiplied by both the 4x and the 2. And the way I do that is by including parentheses and then distributing later on. When I cross-multiply the other direction, I get 3 times x minus 4. So I get a 3, and then in parentheses, x minus 4. And what cross-multiplication does is it allows me to set those two quantities equal. I take some sort of problem that has a fraction equals fraction, and I create just a regular equation out of it that's a lot easier to solve. So when I go to solve, I'm just going to distribute on both sides. So on the left, I have 8x plus 4, and on the right I have 3x minus 12. It's already simplified, there's nothing to combine, so I can subtract 3x from both sides because I want to keep the x's positive when I get them to the same side. Remember, I deal with the x's first. That leaves me with 5x plus 4 equals negative 12. And then solve the two-step equation. You're going to subtract 4 from both sides, which leaves me with 5x on the left-hand side and negative 16 on the right-hand side. So when I divide by 5 and divide by 5, my final answer is x equals negative 16 fifths. And again, I'm going to leave that as an improper fraction. You could make it negative 3.2 if you would like to. So negative 16 fifths is the solution to my proportion. And I remember that in order to solve for proportion, I cross multiply and distribute as necessary.